Hi everyone, how to trace and track the voltage into laptop motherboard or computer motherboard. So this schematic is for D latitude 5480 and 5488, but the working principle is the same. So guys, I guarantee for you that if you follow me and understand this video and all what I'm seeing here, I'm sure that your vision to motherboard repairing and hardware repairing will be changed 100%, because this is a very exclusive and unique video that will teach you the details on how to trace, track and follow voltage into computer motherboard. So if you understand this schematic, this power sequence that I'm going to teach you, you will be a professional in motherboard repairing. So let's get started. So basically here, this is the motherboard, this is the whole motherboard. Okay, this square and rectangular here means ICs and voltages. Okay, so first note, so this color here, orange color, means the CPU power. Okay, this pink color means the power for the PC head or the NOT bridge with the IC head, and so on. By the way, please don't forget to subscribe, share the video and like the video, because your likes and engagement motivate me to create more and more unique videos for you. And for anyone who want to join me in the Patreon page, where I share and upload every single day in a daily basis laptop schematics and some useful content, you are very welcome in the Patreon page. Thank you very much, and let's get started. So here, as you can see, we have here the adapter. Okay, this is adapter, as you can see here. Okay, and over here we have the IC, the charge IC. Okay, so here we have the adapter and this is the charge IC. The reference for this IC is ICL 88738. Okay, so then we have the battery over here. So here we have adapter that is connected to the charge IC. Then the charge IC will take the 19 volt from the adapter and transfer it to another voltage about 8 volt in order to charge the battery. Okay, and here, as you can see, we have two arrows here, as you can see, means this is the power SRC, means the main voltage that will power the motherboard. Okay, so 19 volt, this is basically 19 volt, usually 19 volt. So this voltage has two sources, the adapter through the charger IC or the battery. Okay, so if you have, for example, the adapter connected, we will use this arrow. The 19 volt will be generated here. But if you remove the adapter, the 19 volt will be generated by the battery. Okay, so this is the main voltage, 19 volt. So we have here 19 volt. So this 19 volt will be distributed to all circuit in the motherboard. As you can see, all this around means 19 volts. Okay, so the first 19 volt will be applied to this circuit. So this circuit is for what exactly? Let's see for what. Here we have plus 1.2 volt memory, and over here we have 0.6 volt DDR VTT. So these two voltages are for RAM. So this is the RAM control IC. And I can even know the type of RAM here. The type of the RAM here is DDR4, because the working voltage, as you can see here, of DDR4 is 1.2 volt. And the voltage for terminal is the half of this voltage, means plus 0.6 volts. So this IC is the RAM control, and over here we have two voltages, 1.0 volt and 0.6 volt for terminals. So remember that the RAM has two voltages, one main voltage and the other voltage for VTT or for terminals. So for DDR1, the main voltage is 2.5 volt and the VTT or RAM for terminals is 1.25 volt. The DDR2, the main voltage is 1.8 volt and the VTT is 0.9 volt. For DDR3, the main voltage is 1.5 volt and the VTT, or the voltage for terminals, is 0.75 volts. And for DDR4, as you see here, the main voltage is 1.2 volt and the VTT 0.6 volt. And the DDR5 has as a main voltage 1.1 volt and the VTT 0.55 volt. Okay, so then this voltage will be applied to another circuit. As you can see, its part number TP22961. Its reference in the motherboard is UZ26. Okay, so 1.2 volt will be applied to this, as you can see, IC, in order to generate plus VCC SFR OC, as you can see. So this voltage is for the CPU. It's usually about between 0.3 volts to 1.5 volt. As you can see, this color, orange color here, and this also is for the CPU power. Okay, we have here CPU power. Okay, and this one we have here, the blue color here, is for GT3 power, or the RAM power. Okay, so this one here we have orange color. This is basically for RAM and of course for the CPU. Okay, because we have this color means this 1.2 volt will be applied to the CPU and to the RAM. Okay, so then the second 19 volt will be applied to another circuit. As you can see here, we have the part number of this circuit, we have SYX198D. Okay, and its reference in the motherboard is PU301. So you can just go to the motherboard and search for PU301 and you can find this IC. So this IC has as a purpose to generate plus 1 volt for what? For the PCH. Do you see this pink color? This pink color means the power is for PCH. So basically the PCH is a chipset that integrates the NOT bridge, the graphic card, and the ICH. We called it the PCH. Okay, after that we will take this voltage and apply it to 3 ICs. As you can see here, the first IC TP is 22961. It will generate plus 1 volt. As you can see, this is also for the CPU, also plus 1 volt, as you can see, for CPU, and it will generate also plus 1 volt PEX VDD for what? We have here green color for, as you can see, the GPU, the graphic unit, for the graphic unit. Okay, then we have another voltage here. Also we have 19 volts. So 19 volt will be applied to this circuit. I'm going to show you the circuits in the schematic. Then the circuit will generate plus 5 volt always. Okay, basically it will generate 2 voltages, plus 5 volt always, and another plus 5 volt always too. Okay, you can see me, where is the plus 3 volt 3? Always here we have plus 3 volt 3 always. In this computer, basically the circuits that generate plus 3 volt and plus 5 volt are separated a little bit. Okay, are separated, as you can see here. So we have here this PU102, it generates plus 5 volt always, and here we have PU100 that generates plus 3 volt always. So guys, here a note, a very important note. I told you in the previous video that plus 5 volt always and plus 3 volt always are a very important voltage in every motherboard. Without these two voltages, the motherboard cannot work properly. I have a proof here. Do you see? Plus 5 volt always. So once this IC generates plus 5 volt always, all these ICs, as you can see, and voltages will be generated based on this voltage, as you can see. Okay, based on this voltage. Also for plus 3.3 volts always, as you can see. So let's see. Do you see? Plus 3.4 always will be the source of all these voltages, as you can see over here. Okay, so without plus 3.3 volt and plus 5 volts, nothing will be happen in the motherboard. The computer cannot work properly. Okay, so this IC will generate, as you can see, plus 5 volt always, and then this plus 5 volt always will be applied to all the circuits in order to generate these voltages, as you can see. So this one 1 volt is for the CPU power, this one, as you can see, is for the PCH, and these 4 voltages are for the G3 power, as you can see over here. Okay, the same here, the voltage will be applied to this IC also, and this IC, basically this IC is for the GPU core, as you can see, GPU core. When you hear the GPU, means the graphic controller, and CPU means the processor, the central processing unit. Okay, and as I told you before, of course, here we have plus 3.3 volt always, that will be generated by this IC, as you can see, is Y8288B. Its reference in the motherboard is PU100, and then based on this voltage, all these other voltages will be generated, including LCD VDD, so the power, the LCD, the VDD for LCD. So without this 3.3 volt, you cannot see anything in the screen or in the monitor. And of course, here we have another plus 3.3 volt run that will be the source of this voltage, of course, for the graphic card, for the CAM, as you can see, plus 3.3 volt for CAM, etc. So here, as you can see, we have, as you can see, other ICs over here. So basically these 3 ICs has as a purpose to generate the voltage for the CPU here, as you can see, because we have this orange color, we have plus VCC SA, plus VCC GT, plus VCC core, and this one basically for the Bluetooth power. As you can see, we have the Bluetooth power. Okay, this is the IC that is responsible to generate the power for the Bluetooth. So as you can see, you will find always for each IC, as you can see over here, as I told you before, this is the reference for the IC. In the motherboard, you will find U or UT is for IC, and this is the part number. Okay, and over here we have, as you can see here, the power. For example, here we have plus 3.3 volt, so this power will go directly through this inductor. This inductor will increase the current, and then the voltage will pass through these capacitors in order to filter the voltage and remove the noise, and then will go directly and power the IC. Here we have 4 VCCs, means all these pins, the IC will be powered in all these 4 pins. So this pink, as you can see, point means we have connection. As you can see, pink point means we have connection over here. So basically here, this is the charge circuit where we have the jack, the power jack over here, basically. So here we have 19 volt. This 19 volt will pass through this current sense resistor. As you can see, this is current sense resistor that is connected to the IC in its terminal, because the IC controls this current sense resistor. This current sense resistor has as a purpose to sense the current and know about the current, is it enough or not. Okay, and then here, of course, we will get the power that will be distributed to the motherboard. Here also we have another 19 volt that will be passed through this inductor. This inductor has the purpose to increase the current, and the power also will pass through these ceramic capacitors. Basically those are ceramic capacitors, and over here we have electrolytic capacitors. Here we will get charger CRC in order to charge the battery, of course. Okay. So as I told you before, we're gonna study 2 circuits. Here we have the first circuit. This circuit is for the CPU or the processor. Then the second circuit will be 3 volt 5 volt circuit. So let's get started. So here, as you can see, this is the control IC for the CPU. Okay, and here we have the CPU channels. So one of my followers asked me what that channel means. The channel means the power source. For example, for the RAM, you will just find one power source or one channel. that gives to the RAM 1.8 volt, for example. Okay, but for the CPU you will find 2 channels, 3 or more, that gives the same voltage. As you can see here, we have plus V core, okay, and also here we have plus V core, because the CPU needs more accurate voltage, and in order to avoid overheating of the component and the IC, as you can see here, and MOSFETs, we called many channels. Okay, so here we have the first channel. This channel basically contain the main component that every channel should contain, including, as you can see, MOSFETs, inductor, and capacitors. Okay, so MOSFETs, inductor, capacitors, and of course the IC. Okay, so this is the first channel. The same for this channel also, we have MOSFETs, inductor, and capacitors. Okay, so let me speak a little bit about the purpose of each component here. So the IC is the controller part. It controls these 2 MOSFETs or voltage regulators. Okay, so these MOSFETs are voltage regulators. It transforms the 19 volt to here the V core 1.1 volt, about 1.1 volt. Okay, the inductor increase the current. Okay, the inductor increase the current in order to get enough current, and the capacitors here filter the current in order to get a continuous voltage. Okay, and of course we have here also these ceramic capacitors, and also for this channel these ceramic capacitors. So these ceramic capacitors basically remove the noise from the signal. Okay, so in every circuit you will find this component. Now let's get and trace the voltage. So let me pick another color, the red color for example here, and let me choose this arrow. Okay, and the width, let me increase the width. Okay, so let's get started. So here, as you can see, we have the Vn. Okay, this is the Vn, about 19 volt. Okay, about 19 volt. So this Vn, in order to get this voltage, we will get this voltage from this Vn. Okay, so this Vn, as you can see, will pass through these ceramic capacitors. So here, these ceramic capacitors, without the ceramic capacitors, we will get a bad signal or a bad voltage. Okay, this 19 volt will pass through these capacitors, as you can see here, and then will goes directly to the drain of this MOSFET. Okay, so I told you before that these capacitors has as a purpose to eliminate the noise in the circuit. So once 19 volt arrives here in the drain of this MOSFET should receive the control signal here from this IC. As you can see here, we have the upper gate, so it should receive the control signal in its gate. So once it receives the control signal, of course these 2 MOSFET will receive the control signals in the same time. Okay, in the same time. So here we have upper gate for this MOSFET, and we have the lower gate, as you can see, for this MOSFET. So once this MOSFET receives the control signal, it will let the voltage to pass directly here, okay, to its source. But it's not 19 volt that will be passed. No, the amount of voltage that should be passed here is about 0.3 volt to 1.5 volt, because the voltage for processor until now is between 0.3 volt to 1.5 volt, depending in the type of the processor. Okay, so let's assume that the V core is 1 volt. So here we will get 1 volt. Then this voltage should pass through this inductor, as you can see. So this inductor has a purpose to increase the current. Okay, because this voltage could be not enough current, so here we have inductor that will increase the current, and then the voltage will pass through this electrolytic capacitor and this electrolytic capacitor in order to get a continuous voltage. Okay, in order to get a continuous voltage here. Okay, we will get here a continuous voltage. Okay, so the same thing for this channel. As you can see, the same steps for this channel. Okay, here as you can see we have the Vin. Okay, here we have the Vin, as you can see. Here we have several capacitors. The voltage here will pass through these capacitors, okay, and directly it will be present here in the drain of this MOSFET. Once this MOSFET receive the control signal, it will let the voltage to pass to the next terminals here, and then we will get here 1 volt that will pass through inductor in order to increase the current, and through this electrolytic capacitor in order to make the voltage a continuous voltage. Okay, so here please pay attention. Here, as I told you before, we will get here about 1 volt. The voltage will go in this direction and also will go in this direction, as you can see, directly to the IC, because the AC also needs to know about the voltage. Is it a correct voltage or not? Okay, so here we have the second MOSFET here in the both channels are used to eliminate the extra voltage, as I told you before, because if we want, for example, to get here 1 volt and we get, for example, 2 volt, the extra voltage or the residual voltage should be eliminated by this MOSFET that is connected to the ground, as you see here. Okay, so now let's see the 3 volt 5 volt circuit and study it. So this is basically 3 volt always, as you can see here, and 5 volt always. Okay, so let's trace the voltage here. So let's first know about the component here in this circuit. Always the same working principle in every laptop in the world. Okay, any laptop should have the same working principle. Okay, so here we have the IC, as you can see. We have 2 MOSFETs. Okay, of course we have 2 channels. This channel is for 3.3 volt, as you see here. Okay, so this channel is for 3 volts, as you can see here. And here we have another channel for 5 volt, as you can see. Here we have 5 volt and here we have 3.3 volt. So in every channel, what should we find? We have inductor. Okay, so we have the current sense resistor in order to sense the current and to get the right current. We have the electrolytic capacitor to filter the voltage, and we have the diode for protection purposes. So let's trace and track the voltage here in 3 volt voltage. Okay, in 3 volt channel. So here we have the Vn about 19 volts. So this Vn will pass directly to these 3 capacitors in order to be filtered, and then will go directly to the drain of this MOSFET. So once this MOSFET is activated or controlled by this IC, as you can see, we have the drive high because this is the higher MOSFET. Okay, we have drive high, and for this MOSFET we have drive low. Okay, for this MOSFET. So once these 2 MOSFETs are activated and controlled or receive the control signal, the voltage will pass through this MOSFET, and here we will get how much? We will get 3.3 volt. Okay, here we have 19 volt in this point. Here we will get 3.3 volt because this is a voltage regulator. Then this 3.3 volt will go directly and pass through this inductor in order to increase the current. And then here we have the current sense resistor. This current sense resistor will confirm and check whether the signal has enough current. Okay, that's why this current sense resistor, as you can see, is connected to this IC here, because this is the control IC. Then the voltage will pass directly through these two capacitors. This is a filtering capacitor. If you see here, we have the capacity of this capacitor is 330 microfarad, 6.3 volt. Okay, this capacitor will filter the current in order to get a continue current over here. We will get a continue current. Okay, so the diode here, as you can see, is here in order to protect the other side of the circuit. This is a protection component. Okay, that's why its anode is connected to the ground. So for this circuit also the same working principle. As you can see here, we have the VN about 19 volt. It will pass directly through these capacitors and then goes to this MOSFET. This MOSFET will be controlled or driven by this IC. Then the voltage will pass directly here. Of course, this MOSFET also will be received the control signal here. So for example, here we should get 5 volt. Okay, we should get 5 volt. If we get 6 volt, this MOSFET will eliminate the extra voltage and connect it directly to the ground. So the 5 volt that we will get here will pass directly, as you can see, through this inductor in order to increase the current, and through this current sense resistor in order to check whether the voltage is correct or the current is correct or not. As you can see, this current sense resistor is connected directly to the IC, as you can see here, in order to check. The IC will check whether the current is enough or not. Then the voltage will pass through this component, this two ceramic or capacitors. Here we have one ceramic capacitor and another electronic capacitor in order to make the voltage or the current a continue, in order to make the signal continue signal. And then we have here a diode in order to protect the circuit. Okay, so as you can see here, this is basically the charge IC circuit, where we have the charge circuit, as you can see over here. And over here, as you can see, this is the input voltage. Here we have the power jack. This is two switches, as you can see. Of course, let's first know about the component that we have here in the circuit. After that, I'm going to show you step by step how to trace the voltage. So here, as I told you before, this is the power jack over here. We have over here two switches. Okay, we called this MOSFET switches because here we have 19 volt, and also here we will get 19 volt, also here we will get 19 volt, and also here we will get 19 volt. Okay, so this is the charge IC circuit. Here we have inductor. This is a current sense resistor, as you can see over here. And here we have two MOSFETs or voltage regulator. Okay, we have inductor and we have capacitors, and of course we have a current sense resistor. So basically, this two MOSFET with inductor here has as a purpose to generate the charge voltage in order to charge the battery. Okay, so now let's get started and trace the voltage. So here, as you can see, we have 19 volt. Okay, this is the power jack. So 19 volt will go directly in this direction. Here we have drain, source, and gate. So this switch or MOSFET, once it is activated or controlled in its gate, of course by this IC, it will let 19 volt to pass to other side. Here we will get here 19 volt. Okay, and then here also we will get 19 volt, and also this, as you can see, MOSFET will be controlled here. We'll receive the control signal here, and we will get, of course, here 19 volts. So here we have 19 volt in the power jack. Here also we will get 19 volt, and also here we have 19 volt, as you can see. Here also we will get 19 volt because this is just a switch, and of course here also we will get 19 volt. Okay, so we have 19 volt here in the power jack, and then 19 volt will pass once the switch is receiving the control signal to this side, and then of course the switch will receive also the control signal, and we will get here 19 volt, as you can see. So here we have the current sense resistor. This current sense resistor will check whether here we have an enough current or not. Okay, so the 19 volt will continue in this direction, as you can see, until we get here the charge B+. So here we have inductor, as you can see. So here we have the current sense resistor. It will sense and verify whether this 19 volt has the enough voltage or not. And here we have inductor. So basically, if the voltage doesn't have an enough current, we have here the inductor that will increase the current. Okay, and here we will get charge B+ that equal to 19 volt over here. So 19 volt, we will get here 19 volts. Okay, so this 19 volt, as you can see, we have here charge B+ will goes directly in this direction. So this 19 volt, as you can see, will goes directly to this point. As you can see here, we have charge B+ that equal to 19 volt. We will get here also 19 volt. Okay, so this 19 volt will be present in the drain of this MOSFET. Of course, here the purpose of the voltage that we will get here is in order to charge the battery. As you can see, we have battery. Okay, so here we have 19 volts. Okay, by the way, here we have charge B+, and here of course we have here B+. This B+ is the voltage that will be distributed to all circuit of the motherboard. Okay, this B+ also equal to 19 volt. Okay, so we will get here B+, the voltage that will be distributed to the whole motherboard, and we will get also here charge B+, the 19 volt that will be applied to this MOSFET. Okay, so here we will get 19 volt. Okay, so let's write over here 19 volts. So we have 19 volts. Okay, so once this MOSFET is received the control signal, here we have the drive high, as you can see. Once this MOSFET received the control signal and also this MOSFET, the voltage will pass from the drain to source in this direction, and here we will get the charge voltage, the enough voltage that will change the battery. Okay, basically the voltage here could be 8 volts, 6 volt, etc. Okay, so the voltage will pass directly through this inductor in order to increase the current, and then through this current sense resistor in order to sense the current, to verify whether the current is enough or not, and then we will get here but the voltage that will charge the battery. Okay, so this is it for this circuit. So this IC is the charge IC, the control IC that helps us to manage and to control all this operation. Of course, I want to add that if you want, for example, to download the datasheet of this IC, so let me zoom a little bit. So the reference for this IC, as you can see here, is BQ24740. So I'm going to show you how to download the datasheet of this IC easily. So let's pick just the reference. Here we have BQ24740. We can just go to Google. So we can just write here BQ24740, okay, datasheet, and press enter. So here let's pick the first result. As you can see, we have BQ24740 datasheet. Okay, so let's choose this first result. Let's hit the first result. So here we go. We have here the datasheet. As you can see, we have here BQ24740. We have the PDF file. So by the way, this website, this is a very important website. So I use frequently this website. If I want any datasheet of any circuit, you can just take the reference of the circuit and paste it in Google, and then look for the website, or just paste it and look for datasheet of the component, or just you can paste it here in the search box and press search. So as you can see here, we get the datasheet. We have here BQ 24740 and we have the PDF file. Here we have 29, P means 29 pages. Okay, so here we have a host controlled multi-chemistry battery charger. Do you see? Battery charger with low input power detect. Okay, so the charge IC or battery charger IC. So just let's click here over the PDF file in order to download the PDF file. So then here we have download. Let's click again over the part number. Here we go, we have the PDF file. As you can see here, you can go directly to this icon if you want to download it to your desktop. Okay, as you can see here, we have one of 29 pages. So let's just click this icon in order to download it to our desktop directly. So here we have a security code. We can just enter the security code. So let's enter 63656 and click download. So here, as you can see, the file is downloaded. Okay, we have done. The file now is downloaded. So let's click over the file. So as you can see, guys, we have the file. We have BQ 24740. We have 29 pages. You can search here and check the datasheet. You can find here all details of this IC. As you can see, we have the pinouts. Okay, as you can see, and as you can see here, we have the thermal functions or characteristic. This is a very important table where we have each pin, as you can see here, and the description of each pin. As you can see, for example, ECN, ECP, all these pins we have here description. For example, EC detect, adapter detected voltage, as you can see. Okay, so you can read in details all about this IC. You can find also the functional block diagram, the conditions about thermal conditions, voltage conditions, etc. as you can see. So you can do the same for all components. You need just part number of any component and paste it in the website and just type search and you will download the file. So let's go back to our schematic, as you can see here. So now let's go to the next page where we have another circuit. So basically here we have another circuit where we have, as you can see here, plus 5 volt and plus 3 volts always. So this is two main voltage in every motherboard, because here we call this voltages always, because always these voltages are exist in the motherboard. Without pressing the power button, you should find these voltages. Without these voltages, other voltages cannot be generated. That's why this is a very important voltage. So let's study a little bit this circuit. Let's study first its component, then we're gonna trace the voltage. So here we have, as you can see, the 3 volt 5 volt control IC. Here we have two MOSFETs for this channel. So this here we have plus 3.3 volt channel here and plus 5 volt channel here. So each channel contain what? Contain two MOSFET, as you can see, inductor, okay, and electrolytic capacitor. The same here. We have two MOSFET, we have inductor and electrolytic capacitor, and of course we need for each channel an input voltage. As you can see here, we have B plus and here we have B plus equal to 19 volts. Okay, so now we have here, in order to generate this voltage, we need first an input voltage that is equal to 19 volts. So this voltage here equal to 19 volts. So let's write over here 19 volt. Okay, so here we have 19 volt. So this 19 volts will pass through this inductor, okay, and then through these two ceramic capacitors in order to eliminate the noise. This is a filtering capacitor, and then 19 volt will goes directly to the drain here of this MOSFET, okay, or voltage regulator. So once this MOSFET receive the control signal, okay, from this IC, as you can see, drive high, it will let 3.3 volt to be passed here, okay, because this is voltage regulator. So here we have 19 volts, okay, 19 volts over here, and of course here we will get 3.3 volt, 3.3 volts, not 19 volt. We will get here 3.3 volt, okay, because this is a voltage regulator. This IC control the amount of voltage that will be generated by this IC. For example, let's assume that we get here 4 volt, not 3.3 volt. So this IC will eliminate the extra voltage, as you can see. That's why this MOSFET is connected to the ground, as you can see. So once we will get here 3.3 volt, it will pass through this inductor in order to increase the current, and then this capacitor, as you can see, electrolytic capacitor will filter the current in order to get a pure current and a continuous current, as you can see. So its capacity is 150 microfarad, 6.3 volts, okay. Of course we have 6.3 volt. The voltage of capacitor should always be greater than the voltage that we will get here. The same here for the 5 volt, always we have the input voltage. It will pass directly through these capacitors in order to filter and to remove the noise, and then through this capacitor here we will get 19 volts. Once this capacitor is controlled by this IC, once this MOSFET receive to control signals, the voltage will pass directly here. Here we will get 5 volt, not 19 volt. Then 5 volt will pass through this inductor, so the voltage or the current will be increased and will be filtered by this capacitor, and we will get plus 5 volt. So here, as you can see, we have the DC jack, okay, so this is the DC jack over here. So here we have 19 volt. In the DC jack you will find always 2 pins, or usually 2 pins connected to 19 volt power rail, and other pins are connected to the ground, as you can see here. So these 4 pins, as you can see here, connected to the ground, and this 2 pin, as you can see, is 19 volt. So 19 volt, as you can see, will pass directly through this component, okay. Here we have basically ceramic capacitors with the capacity of 0.1 microfarad, 25 volt, okay. As you can see here we have 25 volt. You know why? Because here we have 19 volt. So this capacitor here in the beginning basically are here for protection and in order to filter the current or the voltage, because always when you find ceramic capacitors like these capacitors, means they are here to filter the noise, to remove the noise in the signal, okay. So 19 volt will goes directly and pass through these capacitors and then through the inductor. This is inductor. Here we have L, as you can see. So L is for inductor. You will find always the reference for inductor is L or PL, okay. So the inductor here has as a purpose to increase the current of the voltage, okay, because the voltage could have not enough current. That's why we have here inductor to increase the current, okay. Then 19 volt will pass directly through this capacitor also and goes here, okay. Here we have a point over here, means we have connection. So 19 volt will goes directly to the drain of this MOSFET, and then also it will goes in this direction and also in this direction, okay. So here we have 19 volt. It will goes directly in this direction. This diode here, D4, D is a reference of diode, okay, is here for protection, in order to protect this circuit, okay. So And 19 volt also will go here to the drain of this MOSFET. Basically, this is the drain because we have here 4 pins connected together. Okay, and over here we have the source, and this is the gate. And also 19 volt will go also in this direction to this amplifier. We're gonna see all this. So once 19 volt is present here, this MOSFET should be driven or controlled. It should receive the control signal here in its gate. Here we have the control signal, as you can see, ADP drive means adapter drive. Okay, so basically this control signal is coming from the super IO or super input output, and sometimes it can be generated by the charge IC. This is the charge IC. Okay, so once this MOSFET is activated, then the 19 volt will pass through the MOSFET. Pay attention here, 19 volt. Okay, because this is just a switch, and then goes here and goes directly here. Here we will get plus V bar 19 volt. Basically this plus V bar will be distributed to the whole motherboard, to all circuit of the motherboard. Okay, and then also 19 volt will go in this direction. Okay, and this direction and this direction. So we will get here 19 volt in the drain of this MOSFET. So pay attention, those MOSFET here are for what? What is the purpose of this two MOSFET? In order to generate the voltage to charge the battery. Okay, so here we have the IC, the control IC or the charge IC. Here we have two MOSFETs. We have inductor, okay, and we have capacitor. So let's see this side over here, and here we have plus V BDC. Okay, so basically this voltage is to charge the battery. So here we will get 19 volt over here. Okay, and as you can see here we have the gate. So this is the control signal. Here we have the drive high over here, and for this MOSFET, as you can see, we have the drive low. Okay, so once this MOSFET are activated or are driven by the IC, it will generate a voltage about 8 volt. It will generate a voltage, okay, that will pass through the inductor in order to increase the current, and will pass through, this is the current sense resistor, in order to sense the current and to be sure that the current is enough, and then we will get here, as you can see, the voltage that will charge the battery. Okay, so let's see this circuit also. As you can see, for this circuit, as you can see over here, this circuit basically is in order to generate plus 3 volt always and plus 5 volt always, two main voltages. So here we have the plus 3 volt 5 volt control IC, as you can see. So this is the control IC, and over here we have two channels, as you can see. So two channels. So let's pick another color, for example the black color. So here we have the first channel, as you can see over here, and over here we have the second channel, as you can see. So this channel is for to generate 5 volts, and this one to generate plus 3 volt. Okay, what is the main important? First, let's see the main important component here that can be failed if this circuit, for example, is failed. What is the main component that can be failed? We have the control IC, we have these two MOSFETs for this channel, and also this two MOSFET for this channel. We have the inductor. The inductor can be cut. We have, as you can see, this capacitor, electrolytic capacitor and ceramic capacitor. Here also we have an electrolytic capacitor and ceramic capacitor. Okay, and of course we have these capacitors also in the input. So this is basically the component that can be failed in this circuit. If you have a failed circuit like this, you should check the IC, MOSFETs. This input capacitor, it could be shorted to the ground, because here we have the ground. The inductor could be a failed inductor, a cut inductor. So if the inductor, for example, is is bad, you will find here the voltage here and here not. We will find, for example, here 5 volt, but here 0 volt. Okay. And this capacitor also are connected to the ground. It could be shorted. Okay. So all components that are be connected to the ground could be shorted component, except the resistor. The resistor can never be shorted to the ground. Okay, so let's trace the voltage here. So in order to generate 5 volt, okay, in order to generate 5 volt, we need 19 volt. As you can see, this is 19 volt. Okay, here we have 19 volt and here we have 19 volt for this channel. Okay, so we have here 19 volts. So 19 volt will pass through these 2 ceramic capacitors in order to be filtered and in order to eliminate the noise in the signal. Then it will go directly to the drain of this MOSFET. So here we will get 19 volt. So this MOSFET should receive the control signal drive high from this IC. Okay, so once it receives the control signal from this IC in its gate, then it will let the voltage to pass here, but it's not the 19 volt. The 5 volt will be passed here. Okay, because this MOSFET is a voltage regulator. It transforms 19 volt to 5 volt by the control of this IC. Okay, then here we will get 5 volt. This 5 volt will pass through this inductor. This inductor will increase the current. Okay, because the 5 volt here can have not enough current, so the inductor will increase the current. Then the 5 volt will pass directly through these 2 capacitors. This capacitor basically will filter the current in order to get a continuous voltage, okay. And then here we have the test point, the pad or the test point. You can check here using the multimeter whether you get 5 volt or not. Okay, so of course here, for example, let's assume that we get here 6 volts, means there is an extra voltage. So this MOSFET will eliminate the extra voltage and will connect it directly to the ground in order to get just 5 volt. And of course here also this point is connected directly, as you can see, is connected directly to the IC here in order to know whether we get 5 volt or not. The same also for this circuit. We have here 19 volt. 19 volt, it will goes directly to the drain of this MOSFET after filtered by this capacitor, and then this capacitor will receive the drive high signal, the control signal. Then we will get here 3.3 volt. Here we have 19 volt, here we will get 3.3 volt via this voltage regulator. The MOSFET here is a voltage regulator. Its reference is Q24. Okay. Then here, as you can see, the 3.3 volt will pass through inductor in order to increase the current, and then goes pass through this capacitor in order to filter the current, and then we will get here plus 3.3 volt. Of course, you can check this 3.3 volt in this path, as you can see. Okay, so this is the main working principle of 3 volt 5 volt circuit, and this is how you can follow and trace the voltage using your multimeter in the motherboard. But if you understand the schematic, you can easily figure out and imagine the schematic while you check or you test or you diagnose your motherboard. That's why I focus on understanding schematics in order to be professional in laptop motherboard repairing. Okay, so that's it, guys. Thank you very much, and see you in the next video. And please don't forget to subscribe, share the video for other people like you, and please don't forget to like the video, because your likes really motivate me to create more and more videos. And for anyone who has a question, you can ask me in the comment below. Thank you very much, and see you in the next video.